Hello, and welcome to VDK community meeting. I'm going to quickly share the agenda for today. So today we're talking about generative data packs and DevOps for data. This meeting is actually for everyone who is interested in what is happening with VDK, what is VDK, yeah, it's recorded and available to the public. And if you have any question at any time, you can just unmute yourself and ask a question. I really want to suggest not to hesitate to start a conversation about any of the topics that we're talking about here. I invite you to also have the camera on. If you have your camera on, it's going to be on video. If not, if you want to hide, if it's off, it's you're not going to be visible. And today, because I think that we have quite interesting topics, and I think that it can take a bit more time than usual, I suggest that we skip the introductions, but before you speak, maybe today, introduce yourself and say a little bit about who you are. And yeah, if you have a question also, you can just unmute yourself and like a bit introduce yourself before you ask. That's a suggestion. So our agenda for today is Antoni is going to present the latest release of VDK, of what's happening, what we're working at the moment. Then Eva is going to talk about generative data packs work and the research that she has done. And then I'm going to talk a bit about DevOps lifecycle for data. And yeah, at the moment, that's it from my side.
Let's start with generative data packs instead, if you don't mind.
Really, I actually prefer to do some last minute preps and have the review first.
Antoni was hoping for the same, I guess.
Yeah, exactly. I'm not ready. There is no release.
In that case, I am ready. Okay, so I'm going to share. Give me a sec. Yeah, and actually, this is maybe even a like a good introduction to what is VDK. So yeah, well, basically, the reason why I'm talking about this is because I have some experience with DevOps. I used to work as a DevOps engineer for like 5 years before going to community management. My name is Agit, by the way, and I'm a community manager of Versatile Data Kit. So yeah, I have some experience and knowledge about DevOps, and quite recently I was talking to one of my DevOps friends who is also working with kind of data project, and he asked me, so what is DataOps like? What's the difference like between DevOps and DataOps lifecycle? And basically I told him, well, you know, actually you also can like promote data to staging and production environments, and he was like extremely surprised about this. So I figured that maybe this is like one of the information that's, or something that is missing maybe in the DevOps space. So I kind of promoted this a little bit as DevOps. And yeah, I have like, I usually bring this to conferences. Like I have like presented at several conferences at the moment, and next week I'm going to another one. And here's the lifecycle, DataOps lifecycle that I well, came up with by myself, well, after doing some research, because there are like many or like multiple versions of them, and well, usually it's really the same, and just this orchestrated part can be missing or like be somewhere else. But basically, if you already know the DevOps lifecycle, it's kind of similar. And I'm going to now go through each of these phases and just briefly explain how actually we at VDK we are like automating it, each of them, because I think okay, of course, except the planning phase, which I believe cannot be automated really, unless I'm open to different opinions. But yeah, basically, I think yeah, everything else is covered more or less by the framework that we are developing. So basically, so the first phase of this life cycle is planning. this is where this whole journey actually needs to be considered, the whole DevOps, let's say, cycle. And each step needs to be planned and requirements gathered, all the implications and solutions selected on the organizational level. And because I'm actually talking about this also in data mesh concept, I think it's really important that these decisions are made at the organizational level. So each team that is working on their own, like, let's say, data cycle is using the same tools and yeah, so basically this is the most important part, because we know, I guess, failing to plan is planning to fail. So the second DevOps lifecycle step is code, and actually basically here the code is created in order to ingest and transform the data, and then later on to execute it locally and test it locally. So we have like in Versatile Data Kit, we have data jobs, which is basically some code that is like executed in some steps, and they can be written in Python or SQL, which are performing this extraction and transformation. Here also, like the database, which database we're using is also configured. There are also templates that support this process in Versatile Data Kit, and in order just to try this out, it's possible just to install the Quick Start VDK, which is a very simple and easy process. You can find it in our repository. I can quickly share where it is. And just try it out. So in the wiki page, in the installation, here's the whole part of Quick Start VDK to try it out. And yep, so the next step is orchestrate. Orchestration is this ops kind of part. It's where we install actually and configure the infrastructure. So after testing locally, we want to test and deploy the things to production, or like, let's say, test on some staging environment and then deploy the data to production. Like this can be done actually independently of the code step. That's why there could be like a separate ops team. But in DataOps, I believe that DataOps engineers should be doing this. So the environments are set up. This is done with VDK. It's done with VDK control service. That also is installation is also explained in the installation page that I just showed. And also it's providing Git server for the data jobs. So basically when the code is done, we upload to Git, and then yeah, it automatically can deploy the code. So testing is done on staging. Here we want to catch all sorts of like bugs or like discrepancies in the data, and for this to happen, there are alerts. But basically, I think that most of the people are going to test their data like manually on staging to see if it works, if everything is properly set up. And like Versatile Data Kit like supports this testing stage, I would say, with with easier debugging of what kind of error it is. Like there are two types of error, like user error or platform error, and we can easily know if I have made some mistake and I need to correct it in the code. So the next stage is deploy. Deploy means deploy to production. So when we know that the test data is correct, like we can deploy it. Now it can be also available for analysis. In VDK, we have basically a command VDK execute and VDK deploy, which is starting this deployment. Then there is a separate execute step, which I think it's important because here, like everything is running already scheduled and by itself, so we don't have to actually monitor and do anything. I don't have to execute deploy command because like everything is scheduled depending on the configuration. So there's like testing and monitoring also is set up. And for the monitoring, actually, I wanted to just show quickly the operations UI that we have. And here is a little GIF that one of my team members, I cut it out of the one video. So basically, this is a little bit how even in the quick start VDK, you can have this dashboard where you can see I can see all my jobs. These are all my jobs, and I can see the details of each job, executions, like failures, and then I can actually even go and see like logs of each of these jobs if something is failing. But here we can see like a good example, everything is going well. So yeah, basically operations UI is I can see failed jobs, I can see the logs, I can also see there the types of error, and also executions, like detailed execution of each job. And yeah, so yeah, the feedback comes next, and basically where maybe something is missing, maybe some data is missing, some new requirements are popping up, and in that case, the feedback is collected, and then the cycle goes again. So yeah, maybe some questions, or I'm really open to discuss this, maybe because I'm just looking at this from my perspective, but if there are like some additions, I'm really open to hear. If not, we can move on, maybe if Antoni is ready.
Sure.
Okay.
As usual, we do release announcement at the community meeting, which shows some of the latest changes we have done. You can find all the releases in the release. So yeah, there are some of the major features and changes that include from the last month are one. We have now released VDK DAG, direct acyclic graph, which is previously the pre-alpha version was called VDK meta jobs, but that's now a more production ready stable version, which we can release as beta. And it also adds a lot more stability, usability, and documentation improvements. You can check out more information on the plugin page. The versatile dedicated UI, there are some improvements to allow it easier way to share information. We know sometimes when people are browsing the UI trying to troubleshoot some data job and to figure out, for example, they've managed to reach some specific execution. After applying multiple filters, it's not very easy for users to share this information with other people because until now the links were not shareable, and this is something that's been improved, allowing users to basically share between each other their current selections. For example, like in the main explore screens, people can now share through or whatever they filtered. The same goes for the executions, as I gave in the example. This was contributed by the VMware Spark team for VMware internal platform. VDK, on top of this, to make it VDK easier to consume by any open source user, there are some improvements to make it more configurable and integrated and easy to get started. Quick start VDK, which are listed here. By default, authentication is disabled, so you can directly get started with it for playing around and so on. And lastly, now when you're interacting In the last 2 months, we've been working on adding new features to enable users to choose which Python version they want their job to run with. And this month we've added this kind of features to be able for users to be, when deploying their job or configuring their job, to be able to say exactly the Python version. So there's a new option called Python version to the VDK deploy command. So when users are deploying a job, they can just run VDK deploy minus Python version 3.7. Alternatively, they can also do this directly as configuration in the job specific config ini by specifying the Python version as the control, and then when they deploy their job, it will use that version in the VDK control service runtime environment. VDK control service runtime environment supports specific Python versions, and users can understand which are those by running VDK command. There are a lot of more changes that you can see a very quick list for each changes that have been done on. And another interesting thing that it's we have officially a new contributor, Prissy, who has made their first contribution in the last release. This also continues the trend where I think every single release we have a new contributor so far. That's like 10, 12 releases that we constantly have, 14 actually, we have constantly a new contributor to the project, which is pretty nice trend so far. Yeah, that's what I want to share. Thank you.
Thank you, Tony. On the next topic, I would like to share my screen. I hope you can see it. I'm going to be talking about generative data packs in VDK. So here at our VDK community, we recently attempted focusing on what is the data engineers and data analysts everyday routine. And as you may see, we may imagine that people download the tool, probably once install it, and they start using it, either using the CLI or another interface like graphical user interface. However, this does not affect directly the product you produce using for example, data pipelines or any data framework to shape and curate and transform your data. Looking from the standpoint of the data product itself, you rarely can tell what product was used to produce it, because there is no significant features that are recognizable looking in reverse. And with data, generative data packs, we want to change that, and we want to reach and overcome the data product barrier. So the idea is that a VDK user installs a generative data pack, and this plugin automatically expands the data product produced. So in a way, prior generative data packs, whatever plugins VDK or tools, for example, VDK or VDK plugins, we have about 30 plugins so far within our ecosystem you install, remain only visible to the data practitioner eyes. However, when you install a generative data pack, it directly improves the data products in a way that the data practitioner now don't need to deal with trivial tasks and can easily reuse this in different data job workloads. For example, installing the same generative data pack plugin expands the data product in a common way that contributes to the predictability and the data format, and in a way to pave the way for data contracts. What is generative data pack? we tend to think about GDP as a VDK design pattern. And the unique about Generative Data Pack is that by only installing it, it uses the VDK SDK context, and it can expand. It can you can hook to the ingestion processing API. You can intercept the ingestion process done by VDK automatically, and you can enrich or augment the data by adding in a compliant way additional information only present during the VDK runtime context. So the data expansion you may expect is in a modular way or a horizontal way in favor of a vertical, or to be more concrete, if you have a table with one column, installing a generative data pack may produce and append another column to your data automatically and populate the values within this column. So all of your data jobs that use the same plugin are expected to produce a commonly structured data set. So the data expanded may be any data that is specific to the particular plugin. It may be coming from within the VDK context, and I'm going to provide an example plugin we've recently added that uses the VDK context, reads data from it, and expands the data. Another use case is to actually communicate and request this data from another third-party system running or a service, and then append this data to your to expand your data set. Talking about the data modeling, the way that the generative data packs may augment your data sets is by using a standard dimension. For example, here we have a slowly changing dimension type 2. By the way, VDK provides templates to reuse these strategies. For example, this fact table relates to provides foreign keys and uses foreign keys to other tables to join them and builds the common context for one dataset record that may include the customer, the product, and the store at this particular case. So adding another dimension and linking it by key is a standard, well-known approach. Generative data packs includes now the concept of micro dimension. So the idea is that a particular column may contain hierarchical nested objects, so that those objects may describe in a multi-dimensional way particular column on a particular row. And in a sense, before generative data packs, people were producing monosets. And now that we have this concept of micro dimension that unravels a full data structure on itself, introduces the concept of polydataset. So now, depending on database specifics that you may use, you may query by in-depth of this micro dimension and retrieve condition, filter some data subsets based on this nested structure. And another useful application of this approach may be that you can easily automatically discover what data sets are being produced using this particular GDP plugin, for example, that produces a column named micro dimension. You can discover automatically all the tables that contain this column, and then automatically onboard your data sets or pick up your recently enabled GDP enabled data sets automatically for you. So I would like to provide a more concrete example. Recently, we added this plugin that's probably in the browser is purchased. is going to be so when you navigate in the versatile dedicated repository, all of the VDK plugins are placed within projects VDK plugins, and all of the generative data pack plugins are prefixed with GDP. And recently we added this VDK GDP execution ID plugin. What's the idea for the plugin? Usually people tend to ingest some data. For example, here I have an object that contains product name and product description. And I would like to expand this data set or with some system information that's contained within the VDK runtime context. For example, execution ID. What's execution ID? When VDK runs, it may be locally, it may be in the cloud, in Kubernetes. Each workload execution has a unique ID assigned to it. So before installing generative data pack, when you ingest this data, it looks like that. I will simply create the structure and create the table if it doesn't exist in the database, and then I want to ingest. So I want to store this data into persistent storage, and the way to store it, I may provide a dictionary with product name and provide a destination table. So I will eventually receive 2 columns in the database corresponding to the objects ingested with job input sent object for ingestion framework API. And now when installing the GDP plugin, this data upon ingestion is automatically augmented and another column is added, another object field is added. It is named GDP execution ID. That is also by default, this is configurable. And the value is automatically propagated, automatically detected. There is also an example of how to use how to use the plugin is documented with the plugin README, and there is another additional example that is linked in the README as well. It's a sample data job that uses the plugin, and you can run and see the effect out of the box. So I am going to use this sample data job. It uses SQLite for persistent storage. That, however, for the purposes of the demo, and this is why I needed a bit more time, I wanted to use PostgreSQL due to some specifics. So I will be showing you a slight variation of the example in the repository. So now I have a Postgre Docker image running, and I have configured the access to the Docker image. Like I would like my default database to be Postgre. I'm using DB default type in VDK section in config ini file of the data job. And then the ingestion method is also Postgre. And then I have some credentials to connect to this database. There is another configuration that needs to hook the GDP plugin to the ingestion pre-processing sequence. So I have configured it so that the VDK core actually goes back and triggers the VDK GDP execution ID plugin while ingesting. And then I've adapted a bit the SQL step so that I create the database, the table if it doesn't exist. And the second step, I send an object for ingestion. So here I provide the payload. This is my entire data object. And then I provide a destination table. So when you start any job for development purposes on your local system, usually use VDK run. So I will do that. And then I'm going to provide the name of It's probably the directory where the sources are. It matches the data job name. So now I can see that if you notice, there is a unique ID printed. This unique ID corresponds to the unique execution ID assigned to this particular data job run. If I run it again, the ID is going to change to some other unique value assigned by VDK core automatically. So what is the business problem that the plugin solves? When you take a look at the table at the database, here I am showing the Postgre client I'm using. Then you see, before installing the plugin, I would only see the data object I originally ingested. However, if you imagine a production use case when you have a lot of data jobs producing large data sets, the problem is that these values become anonymous when they land in your storage. So you cannot actually correlate back that this record was populated by one job execution or another. And that certainly can be a problem that we want to solve. And using the GDP execution ID plugin provides you with a tool set that automatically populates and appends to your data set the execution ID that that is actually a mapping to the unique data job run you used. So now, when you look at your data set, you can filter, for example, by execution ID. You can understand, was it a local test development data job run that populated the data, or was it a cloud run that populated the data? And you can learn more about this particular execution ID by listing all of the executions that were performed for this data. For example, I have run this data job in my local cloud setup. And this is the execution ID corresponding to this particular run, I can now sync the record in the database. I know that this particular row was started by particular person, started by, looking to find it. It's probably a configuration. I can see the Python version you used. I can see the status at the time. I can see the job name, if it's scheduled or not, when it started, and so on, some details about this particular execution. So that is an example of generative data pack that we found useful to facilitate having non-anonymous data in the lake and cross-referencing and data populated with the actual workload it got the data in the storage.
So thank you, Eva. I think if there are any questions now, we can kind of have a discussion on this.
This kind of generative data packs would potentially, it will be interesting because you can create a lot of different plugins for different ways you can curate the data. So this could also cause this And there are also very specific type of plugins like generative data pack plugins. I'm just thinking that we already have like 20 odd plugins, which are pretty standard. And as their number increase, it will become harder and harder for people to figure out which plugin to use and how to use it. That's something that we will need to think as the number of plugins increases in the future.
Yeah, for now we are using a flat structure to describe. There is a directory to identify each plugin name, and you can zoom in. So, are we considering some type of categorization for plugins, or?
That
don't
would be
know.
nice, and also document them properly, like, so people can find the users. I think it needs to be in the user documentation also when we are working on documentation. Because as far as I know, but I don't know actually. Yeah, basically what I'm saying is that this plugin documentation, if I go to wiki, is or not easy to find, or I don't know where to find.
Yeah, okay.
So it's a good idea. I just have like a question, like all these plugins that we have are compatible, because my experience working with plugins is kind of a little bit tricky. I have seen when installing one plugin is like destroying another one, and like everything can crash.
Yeah, that's a very good question, and thanks for reminding me. I shared my screen again, so when you go to the configuration, there may be another plugin that you want to execute. Like, you have this ingestion. Every object sent for ingestion is being processed by VDK, and you can register a plugin to intercept this processing, and you can have two plugins reading the data sent for ingestion and, for example, validating it, or you can change it in a way, modify it, and then the next plugin in the chain sees the already pre-processed by the first plugin data for ingestion. So having that in mind, this VDK GP execution ID supports enabling, it leverages the VDK standard approach to intercept payload pre-processing in VDK, and it shares it with other plugins. For example, it can participate in a particular ingestion pre-processing order, chains of plugins that are ordered in a particular way. So I would have the plugin one intercepting the data at first, then I would have the VDK GDP execution ID, and then I may have another plugin and so on. So this is a way to deal with compatibility.
It's nice. If there are maybe questions, I think we can kind of slowly wrap this up. I have a suggestion for the next community meeting for the date. It could be 28th of June. Does it fit us? Does it work for Bulgaria?
Well, I can comment basically. So in June, we don't have that much vacations. So sounds great.
Okay, good.
Yep. Sound good?
So just to finish this, I'm gonna share my final slide of my presentation. I usually finish my conferences like this. I say thank you very much, and feedback is very welcome. I just saw a typo there, and yeah, we're yeah. If you wish to contribute, actually, one of the easiest contributions to Versatile Data Kit is giving us a star because it shows us support. Other ways are just sharing our content and checking also our YouTube videos. And another one, of course, is any type of actual real contribution. Also, feedback is very, very welcome. We are now searching for the people who would like to use VDK and just give us some feedback of how it works for them, because we're trying to be user driven or feedback driven. And if you have anything when you try VDK, have any feedback, please let us know. So yeah, thank you everyone who joined. Thank you everyone who spoke, and see you next time. Bye.
Thank you. Bye.
Bye bye.